Hi everyone, thanks for coming out. There's a lot of you. I'm kind of surprised by this, but awesome. That's great. My name is Matt Stoltz. I run a group called 3D Printing Providence, which is a meetup group for people interested in 3D printing in Providence, Rhode Island. I'm an ex-Hackerspace founder from Pittsburgh, so I founded a Hackerspace and was president there for 3 years. Moved to Rhode Island after going to work for MakerBot and left them because I wanted to do more with you guys. And have a lot more fun with the community than I could have. So one of the things I'm really interested in for 3D printing is materials. You're going to go over and walk through the 3D printing village and you're going to see dozens of different designs of machines. You're going to see 80, 90, 100 machines around this entire fair. And we're getting really good. We as a collective group are getting really good at making 3D printers. We're getting this figured out, especially FDM machines. Like, you know, they're all starting to kind of even out in their functionality and what they can do, and you know they're getting really nice. So how do we take it to a next level? How do we make our prints better? How do we make our prints more useful? How do we make prints that we couldn't make even before on our standard printers? We can do this with materials. We can change the plastics that we're using and therein be able to make better prints. We have been making plastics, you know, and using some kind of plastics for, you know, millennia. So 1600 BC, you know, they started taking natural plant resins and mixing them together to make rubbers. But back in the late 1800s, early 1900s, real synthetic plastics really started to come into play. And then after World War I and into World War II is when we really started understanding the chemistry of plastics and really taking over plastics. In today's world, try spending a day not with plastics. You can't do it. We're all covered in plastic. You know, our phones are filled with plastic. Our homes are filled with plastic. You know, there's just plastics everywhere. And there's hundreds of different types of plastics. But in the 3D printing world, we've basically been kind of sticking to two different types of plastics. We started looking at there's gonna be more coming. There's more thermoplasts, you know, more plastics that you can heat up, shove through a nozzle and make them come out that are coming forward. End of last year, I think after Maker Faire, shortly after, my good friend Tony Boozer over here in the corner, he and I were having a discussion. We said, you know, what's going to be the big 2013 thing for 3D printing? And we said, you know, plastics. We're gonna start to see more. And the market really didn't surprise us. Within the past year, there have been a large growth in the number of plastics that have come to the market. But for the most part, everyone's still printing in ABS and PLA. So let's fix that. Let's change that. And I'm going to explain a little bit more of why we should. So yeah, common 3D printing materials, ABS and PLA. If you have a MakerBot Replicator 2, you're pretty much printing in PLA. They don't have a heated build platform. You need a heated build platform. But you know, if you've been in the RepRap world or the MakerBot world, or you know, a lot of these other printers for a long time, you've probably run into ABS. You've probably run into PLA. That's what you're printing in. Real quick, who all here has a printer? Awesome. So now we're getting a lot more coming out. We've got ABS, we've got PLA, we've got nylon varieties, PET, HIPS, polypropylene, PVA. All these different plastics are now starting to come to the market. And they all give us different functionalities based on their own physical and chemical properties that they have. And being able to leverage these properties really makes it so we can start pushing forward and doing a lot more with our printers beyond, you know, the kind of applications that we've already seen over and over again. So I've got 3 different varieties of ABS on the stage here. We've got, you know, our kind of traditional standard ABS. You need a heated build platform to be able to print I forgot something. Oh well. You need a heated build platform to be able to print this. You're typically going to print it onto Kapton tape, that gold tape that you see the covers of 3D printers coated in, or the build plates of 3D printers coated in. That'll make it adhere to the plate and keep it from warping or changing. So, each of these different types of plastic are going to have different print characteristics that you're going to have to work through. This is a thermochromatic plastic, so it actually has an additive in it. I don't know how well you guys will be able to see it, but it reacts to heat and so, and it changes color as it starts to print. Now, that's kind of silly. It's kind of interesting. It makes fun little things, but we can start making things like coffee mugs. We can start making things that react to temperatures. I've heard that there is someone else here. I need to go hunt them down that has one that reacts to cold. Yeah, I need to go talk to those guys and find out what filaments they're coming out with. So, because I want to play with more. I have a conductive ABS, so it has carbon mixed into it that gives it a conductivity. This is actually a really high conductivity. It's not really great for making circuits right now, but it's being worked on. There's a filament out there called Carbomorph that a university project put together that actually conducts fairly well, and so Carbomorph, yeah. And so they've been able to actually make flashlights that you print out a flashlight, put in a battery, put in an LED, press the button, the button's printed, everything, and it works. So we're, that question that we all get of, oh, when can I print something useful with your printer? We're going to be able to print circuits here soon. Standard PLA, once again, PLA now, we get rid of that heated build platform. We're now printing cold onto, blue painter's tape or other surfaces that it will adhere to. I like blue painter's tape, that's my preference for PLA. But low shrinkage, so we don't need a heated build platform. It prints great. So now we're starting to see some PLA varieties start to come in also. So this is Laywood. Laywood is a mixture of PLA and wood fiber. Mostly there for kind of neat aesthetic reasons. It can do some very, very cool things where you can actually sand it and it really comes out looking like wood. You can stain it to some degree. If you vary the temperatures or the speed that the extrusion is going through, you can actually kind of burn the wood a little bit and give it an effect that looks like growth rings on a tree into the actual print. So it really, really comes out looking like wood, and it's really nice. It's kind of fun. The same gentleman who created this just released a new material that he refers to as lay brick, which has a sandstone feel to it. So the gentleman who designed all of these models is a sculptor, and he's very interested in the idea of making these sculptures that actually look like they're coming out of stone, and the lay brick really gives that nice effect of a stony effect. We also have nylon varieties. Two of them here are Tallman 618 and Tallman 645. 618 has a lot of flex to it. It's very strong, but it does have some give to it. This is really nice because nylon is really unreactive to other things. This is where we really start to get into the materials that really expand some of our capabilities. Because with nylon, I can print molds directly in this. They have flex to them, but it won't interact with urethane. So I can print a mold and cast parts directly into this, and then be able to flex the material, pop out the parts, and they won't stick to the nylon. We've also had some people kind of playing around with it for printing some automotive parts because it won't interact with gasoline. It's safe for gas. So there's a lot of potential there, and it's also really, really strong. So it's nice. The problem about nylon though is its non-reactivity. It doesn't like to stick to anything. So where we need to print onto heated build platforms or blue painter's tape to get nylon to print, finding the solution to get nylon to actually stick to something ended up being a big trick. One of the things that we discovered that nylon sticks really well to is not my hands, is nylon sticks really well to nylon. So the thing that I forgot to bring is I have a nylon sheet that I adhere to my build platform that I've just scratched up and scored up. I take really rough sandpaper and sand it. I take razor blades and cut hatch marks all through it to try to give it a really rough surface. And my nylon models stick great to it. I don't have curling issues. It adheres well. It prints really, really well. And now I have this, this strong material that I can print with. The Tallman 645 is very similar to this 618, but it doesn't really have the flex. It's even stronger. So if you're really trying to make parts that need to hold up to a lot of physical abuse, this is a really great material for doing that. Tallman, the same company, recently released a PET material. So PET is the same material that you find your plastic water bottles being made out of. So recyclable, which is nice, and should technically be food safe. They've added some additives to it to make it really strong also, so they refer to this as T-glaze or T-glass. And it's really hard, it's really strong, but it has really nice optical clarity to it. So just like your plastic water bottles are clear, you can actually print this. I did not print this in such a way to keep it clear, but you can print this at higher filament thicknesses or extrusion thicknesses and actually get it to have a really nice kind of crystalline clear structure to it, which is really great. But it's fairly new to the market and it's something that is still kind of being experimented with, but it prints really well. It goes right onto blue painter's tape without a heated build platform, perfectly fine. Prints at about 220, great. So it's a really easy material to work with. There are some, outside of Tallman, there are some other vendors that are selling straight PET also. So there's a couple people out selling HIPS, and HIPS is one that's really kind of got me into this and really got me excited. So HIPS is high impact polystyrene. It's the same kind of stuff that a lot of food packaging comes around, but it prints great. It's really, really nice. I actually like printing in it better than I do in ABS or PLA. I just think it actually comes out with really nice prints. But it also interacts really well with ABS in some fun ways. So when we start looking at these materials and these interactions, the real trick to this is when we start mixing materials. What happens when we have a dual extrusion machine and we start printing in more than just one material at a time, and we start taking these different abilities together? I first started out with the nylons and trying to print nylons with other things, and like I said, nylons won't stick to anything, so nylons don't really interact well with each other. But HIPS sticks really well. So your dual extrusion machine no longer becomes about two colors. It comes about mixing two different types of material. So I can print ABS and HIPS together. Unfortunately, I had some really good models to show you guys of some of this stuff that were over at my booth, and someone stole them about 15 minutes ago. So if you see anyone walking around with a little black and white cube and a little hollowed out cube, punch them and bring it back. So, yes, so ABS is my main material and HIPS is support, exactly. So I print and you can see a little bit in this model, I print in ABS, so everything black here is ABS, and inside of this cube, it was filled with HIPS. And then I can take this model and put it into a solution of limonene, which is a natural, what's the word I'm looking for? It's a natural solvent that, thank you. I'm getting tired. It's a natural solvent made from lemon peels and orange peels, and it's able to dissolve away all of the hips, leaving behind only the ABS. So this means I can create far more complicated structures. You could not do these overhangs and have them be clear with a standard FDM machine. You need to have support. What's the difference between that and PVA? PVA, the PVA varieties that we're mostly seeing on the market right now, they don't adhere really well to ABS. They adhere okay to PLA, but not that great. So once again, I look to my friend Tony. Tony really got me kind of down this road, and he did some of the early experimentation with PLA and PVA, and kind of got things working. But PVA is finicky. So PVA is polyvinyl alcohol. Yeah, polyvinyl alcohol, and it can actually be dissolved in just plain water, which is really great. But then again, you also have to keep it in basically a Pharaoh's tomb to keep it dry after you open the package, before it just goes totally bad. So it's expensive, it goes bad quick, and it doesn't adhere well. So it's nice because it dissolves in water, but when you add all those things together, it's kind of a pain in the butt. Hips, I keep printing in hips. I've had the same package open for 6 months, and I have no problems with it. Limonene, yeah. So, which I just order off Amazon, and it's easy enough to get. No, so nylon doesn't really stick to anything.
That's a shame.
It just sticks to itself.
Best layer bonding.
Yeah.
Better than anything else.
Yep.
You can get something like a channel that's water soluble.
We're gonna keep on working on it. We're gonna keep on working on it. So, this is all experimentation. This is all, every time I find out that a new material has hit the market, I send them an email. I'm like, can I get some? Or I just order it. Europe is getting a lot more filaments than we're getting, which is kind of a shame. And so, and shipping tends to be a pain on them. So, but we're getting to this process. So here you can see the one of the models that I had, the Hilbert Cube, designed by Tony Booza, that I printed. Everything white here is hips, everything black is ABS. Here it is floating around in a little jar of limonene, and that is the final print that comes out. So as you can see, anyone who's familiar with an FDM machine, you would not be able to print that and get that to stay on a normal machine. And that's really neat. It's really cool. You can do really nice sculptural work because you can do all of this. But where it gets exciting to me is mechanics. Now, because I can do two materials and I can melt a material away, I can do things like printing gearboxes or printing other mechanical movements, fully assembled, fully printed as one piece, and then dissolve away any support material that's needed in the middle to keep them from adhering when they're first printed. And then you have a fully working machine in the end. Somewhere, I think that one I left in for about 24 hours just to make sure it was totally 100% clean. But after probably about, leaving it overnight, 12 hours or so, you can start kind of smearing it away and picking it away. From the people that have been experimenting with it since I released this, I've heard different numbers from different people, so. If you leave it in too long, it will eventually start to eat away at the ABS and leave your ABS more soft. But if you kind of get it in just long enough to get rid of the hips, as you can see, this is perfectly strong, great ABS. So, and it leaves all your prints, at least for a few months, smelling like oranges, which is kind of nice. I like oranges. I haven't done it yet. I bet it would work. Have you done it? PLA and hips? Have you tried it yet? Not as well? Okay, so not as well. It might work. experiment with it. Send me an email. Let me know. I'd love to know. I have not really gotten on that. I will say PLA is really nice. A lot of people print in PLA. A lot of people really like PLA. I like ABS better. And the nice thing is HIPS and ABS have almost the exact same print temperatures, characteristics. So you need like a 110, 115 build plate for HIPS to print well. Same thing for ABS. So they print so similarly that that's what I use together. What machine? I'm doing most of my research on a MakerBot Replicator 1. Dual extrusion MakerBot Replicator 1. For the heat bed? So the Rep 1 has a heat bed on it. So it's the wooden box before they switch to the pretty closed source black box. The HIPS does need heated bed. Yeah, so it prints on a 115 heated bed. Which materials are good for the machines without the heated bed? Any of the PLA varieties will go fine. PET will go fine, and nylon. So all of those will go without a heated bed. The only thing that you need with the nylon is to put down a nylon sheet so it's capable of being printed. Where can you find the materials? Here's another example. We'll get there in a second. So here's another example of a model that I did. It has a lot of overhangs. There's no way to print this. So I was able to print it with HIPS support. HIPS also tears away as a tearaway support material. It tears away from ABS very well. It adheres during print time and then removes cleanly. So I'm able to manually remove most of the HIPS and then just dissolve away the last remaining bits afterwards. This model is over at my booth in the far end over here, so if you want to see how this actually came out in the end, I have them over there. Where to get the materials? Filico.com. That's where I go to get HIPS. They are a great supplier. They are the kind of end user end of Village Plastics, who used to be one of the main suppliers of just about everyone's materials out there. But they're releasing some interesting stuff, and the first thing that they did was release HIPS and put it out there, and they didn't quite know how awesome it would be until we started playing around with it, and now I've sold a lot of HIPS for them. Tallman.com. Tallman is the producer of all the nylons and does the T-glaze PET. He is great. He is coming out with new filaments all the time. He has 2 new nylons on the way to the market. The next one will be FDA approved, so it will be totally food safe. So that's going to be a lot of fun. And MakerGeeks.com. I just found these guys a little while ago, but like I said, there's a lot of stuff missing on the market that, here in the U.S. that is pretty prevalent in Europe. And MakerGeeks actually seem to be importing a lot of stuff and selling it. So if you're looking for some of the exotic stuff, MakerGeeks.com is a great place to get it. And they even have an exotics variety pack, so you can just get a couple 10, 20 feet of small samples of a lot of these exotic filaments to just give them a try and see what you like. If you want to see more about my research and more about the different stuff that we're doing, 3dppvd.org is the meetup group that I run, and where planes. Dead silence. Okay, sorry. 3dppvd.org is the meetup group that I run, and where I post all of the research that I'm working on. We're in the process of kind of taking some of the filament research that we're doing and get a little bit even more scientific method behind it to try to really produce something really useful for the community to explain what all of these materials are really good for, and hopefully push some of these vendors to continue coming out with new and interesting materials.
So we're to join up and help you guys with the research?
Shoot me an email. Right. So yeah, all of the 3D printing companies are going to tell you to use their filaments. It's absolutely true. So this is all kind of use at your own risk, experiment at your own risk. But MakerBot wants to make sure that you're getting, a constant, level of user experience. And so they want you to use their materials because they also want to sell you their materials, but also so that when you call up and say, my bot's not working, it's not because, you tried to put weed whacker line through your, which people are doing. Yes. How do we find out more details? That's one of the things, like I said, we're trying to do a little bit with the community side of things to really start documenting some of these things, and then we're going to start pushing. Once there's enough of us saying, hey, we're using other filaments, hopefully we can get enough of us saying, hey, tell us what's in your filaments. I mean, a lot of these people are going to want to keep their recipes a little bit of a secret so they stay proprietary, so they're the only ones selling these things. But, hopefully we can get them to be a little bit more upfront with them so that we can know, better what's in there and, what that is going to do to our machines / our health as we use them. But yeah, right now everyone's being a little hush about it for, mostly intellectual property reasons. Any other questions? Yes. I don't know. I really don't know. I've been actually trying to figure out that myself. So the gentleman who's been coming out with the lay wood, the lay brick, and now he has Benlay, which is a flexible version of his filament. I believe he lives in Europe, and so he's producing them there and releasing them there. And it just seems like there's a lot more people kind of experimenting with what's going on over there. I don't know. We keep discussing going over and just buying a bunch of filament and bringing it back. So.
Does your research include whether the filaments are laser safe or not?
No, that's a really good idea. So yeah, that'd be very interesting. So, and that's something you have to keep in mind if you're going to research with filaments is pay attention to the bot that you're using. Pay attention to what all you're working with. There's another material out there that I really want to start printing with called polycarbonate, PC, but you need to bring that up to about 250, 260 to be able to extrude it. Most of our extruders out there have somewhere close to the extruder end have some peak insulators, and those will break down into toxic chemicals at about 250, 260. So 5 minutes, okay. So you kind of have to be careful of what you're experimenting with and make sure that it will work with your machine without causing any problems.
So the polycarbonate and a lot of these materials are all going to be found on one of those websites.
Polycarb's a little hard to find. You'll have to do some look for it, but almost everything else can be found on the others. Probably yes, because they are two different systems of how it's working. I don't know necessarily enough about injection molding to fully answer that question, but that would make sense. Yes. Well, one second. This gentleman, I've been ignoring him for a few seconds. So go ahead. What was that? Yeah, I don't have a modified extruder. I'm trying to do all of my research on stock material, on stock machines. That way, as I'm passing it out to all of you guys, I'm not really altering anything that you wouldn't be able to do. If I do make any changes, I will note that in the research that I release for sure. What was that? Speak to how some of these materials behave when they fail. Not really. I mean, different ones are different ways. One of the reasons I don't like printing in PLA that much is I find it really brittle and it breaks a lot. It doesn't have a lot of give to it. It snaps more readily than a lot of other things. I've actually been really, this is kind of sad. I've been a little disappointed with the lay brick. This is my second one that his feet have broken off. It's really brittle. So the PLAs to me always seem a little brittle. The nylons, I haven't. This is actually one of the tests that we're about to start doing is stress testing. The nylons are so strong I haven't been able to break one, like trying thus far.
Is that the same with the 645?
Yeah. So we're going to start stress testing some of the nylons to actually figure out what we mean by strong. What would I recommend is the best to start with? It really depends on what you want to do. Do you have a printer right now?
I want to buy one, but I don't feel like I'm going to application. Running car parts like that.
You can start with some Tallman 618 right here. So, and anyone else who wants to play around with some, come meet me on the side after the talk. And Tallman was nice enough, since I was doing these talks, to give me a bunch of 618 to give out to all of you guys. So, get started with nylon. It's awesome. 1.75. So if you have a 1.75 extruder, come see me after.
Have you been experiencing any bleeding with the nylon?
Bleeding?
Yeah, like when if it goes over an empty can kind of thing. I've been getting a lot of that.
I have not had any experience with that yet. So, 1 minute? All right.
Is this also on your radar with the heated build chamber?
Anything with a heated build chamber is on my radar. I haven't actually heard about that one necessarily, so that's not directly on my radar. But heated build chamber will be very interesting. You can get your chamber fairly well heated if you just seal your bot up fairly well. So put it in a big plastic box, and the heated bed and the extruder will keep it fairly warm in there. The drafts cause more problems than not actually having a heated chamber for the most part. The best finish? I really like the finish that comes off of hips just plain printed. A lot of people have been pretty amazed looking at that, at how clean it is. But as far as finishing techniques go, you can do a lot more with ABS than you can pretty much anything else. So that's probably the end. Yes, ask more questions. I will be at my booth if you kind of follow this fence the whole way down as far as you can go, I will be down there. So come check me out, ask me any questions. I'd be more than happy to answer. And I'm gonna hang out to the side here in a second. If you want any filament, come see me.